180 volt. This is one driver inside of the fixture. Power's coming into the fixture and power's going out of the fixture. We don't have 480 volt here to show, but we do have 120 volt. So I'm showing that here. We've got the 3 wires, the green for ground, the white for neutral, and the black for the hot wire, hooked up to the input coming into the driver. All right, so if we wanted to verify that voltage, which is what I did, just come across one of the leads, one of the hot wire to the ground. Does it read anything?
120 volt.
So there's the 120 volt. So I've got it between the black, the line, and I also have it between the ground. Now I'm going to come over to the neutral, the common wire carrying through. Do I have 120 again? Mm-hmm. Yeah. So got 120 now. All right. So then I got a bad. There it is. Right. Okay. I'm going to go back over to the neutral. I should have it again.
No.
All right. We have power to the driver. So in the case of Port Arthur, I've got, it's a little bit different. There's 2 hot wires, but the bottom line, I had power going in. This is the transformer. We've got voltage coming in, and then we got voltage going out. The voltage going out, in this case, is 24 volts. We're supplying a voltage to LED fixtures. I went ahead and put the Kasambi in here. The Kasambi's taking the 24 volts coming out of our transformer and going into the control system. Now here, same thing. We should be able to, let me back up. AC, alternating current versus direct current, is that, yeah.
Land operative, DC is normally a battery.
Okay, so in this case, so the 120 volt at your house, the 480 volt, it's alternating current. AC power coming in, but then it's DC power going out. The meter, it's a different type of voltage, and we just switch over here, and we should be able to test and see 24 volt on this side. Hopefully, if I can get in there.
You got some power, you're just not touching it. Right?
All right, so let's do this. I'm disconnecting the fixtures and just coming straight to the output. And damn it, I better have some voltage right now.
Yeah, 24.
Okay, so 24 volts. And there's a label, there's label on drivers. The label tells you the input. This transformer driver will take 100 volts, will take 240 volts, it'll take 277 volts. It really doesn't matter. As long as we've got the line, neutral, ground hooked up, any of those voltages will work. Transforms it, takes AC power, turns it into DC power, and then we got 24 volts going out. We know this driver works. Now, in the case in the field, I knew that I had a good driver because I took the leads from the one that wasn't working and moved it over and turned the power back on, and boom, the fixture turned on. So I went through that and I made sure. The first thing I did, I made sure the connections were on this side. I decided I didn't want to screw around with the meter, but what I did do is I just switched around the leads on the DC side and made sure that I think this one's bad. Well, let me take the next LED fixture's input. Let me take these 2 wires that are going to the next port slider, hook it up to here, turn the power on. It still doesn't work. Well, guess what? This one's bad. And that was a process. I didn't feel safe doing it with 480, so I just did manual. Turn off the power, move these leads around, played musical drivers across 9 fixtures, and I didn't have to screw around with the last 3 because they were working. I knew they were working, and there wasn't any reason to do anything different.